Hi, welcome to part 5 of electromagnetic induction. In this video, I shall explain the solution of question number 6.3 of page 230 from NCERT Physics textbook part 1. So again, it would be better if you have the book with the question in front of you. Please note the page number once again. The question is on page 230. The question says that there is a long solenoid with 15 turns per centimeter and it has a small loop. The small loop is given by this green color. It's placed inside the solenoid and it's normal to the axis of the solenoid. And if the current carried by the solenoid changes from 2 amperes to 4 amperes in time 0.1 second, then what is the induced EMF in the loop when the current is changing? So we need to find out what is the induced EMF. Before I proceed with the solution, I would like to give a quick recap of the Ampere's Circuital law. The law states that the line integral of B dot dl is equal to mu naught IE, where IE is the current enclosed by the loop and mu naught is the permeability constant. So the solenoid can be represented by the dots and the crosses, because the current through each coil, the current in each coil can be shown as coming out on one side and going in on the other side. So the side of the solenoid in which the current is coming up can be shown with dots, and the side of the solenoid where the current in the turns are going down can be shown as crosses. We know that solenoid is a cylindrical coil that produces uniform magnetic field, very identical to that of a bar magnet. So inside the solenoid, the magnetic field is parallel to the axis of the solenoid. If this is the axis, the magnetic field is also in this direction. To calculate B, the magnetic field produced by the solenoid which carries a current I, we use Ampere's Circuital law. The law says that line integral of B dot dl is equal to line integral of B dot dl is equal to mu naught I enclosed. So we find out what is there on the left hand side. We take a loop A, B, C, D. Now once we do the line integration of B dot dl, we realize it's equal to A to B. We can break the loop into 4 parts: A to B, B to C, C to D and D to A. So the first integral B dot dl from A to B, the dl and B, between dl and B the cos theta is equal to 1 because theta is equal to 0. So B dot dl from A to B becomes equal to B into H. B is the magnitude of the magnetic field and dl is equal to H. The second integral from B to C, B dot dl will become equal to 0 because dl, that is B to C, and B are, the angle between them is equal to, theta is equal to 90 degrees. So cos theta becomes equal to 0. So B dot dl, second integral, becomes equal to 0. The third integral, C to D is also equal to 0. Here this is equal to 0 because for an ideal solenoid, the external field, external magnetic field is considered to be 0. The fourth integral from D to A is also equal to 0 because here again DL, that is DA and B, the angle between them is equal to 90 degree. So cos theta is equal to 0. So right hand side line integral B dot DL becomes equal to B into H. So we can rewrite the Ampere circuital law as B into H equal to mu naught IE, where IE is the current enclosed by the loop A, B, C, D. The loop can be thought of enclosing straight conductors carrying current I, each of them carrying current I, because the loop encloses N1 turns and each of the turn can be shown as a straight conductor carrying current I, because the solenoid is carrying current I. So each of the turns would obviously carry the same current, and each turn inside the loop can be thought of as a straight conductor carrying current I. So what is I enclosed? I enclosed is the number of turns enclosed into current I, because each of the turn can be thought of as a straight current carrying conductor. So what is N1? If N is the number of turns per meter of the solenoid, then we can write 1 meter. In 1 meter the number of turns is N. In H meters the number of turns is N into H. So N1 is nothing but N into H. So current enclosed can be written as NHI. So now coming back to this equation, B dot H becomes equal to mu naught NHI. The H here and the H here cancels and B becomes equal to mu naught NI. We are going to use this equation for calculating the magnetic field produced by solenoid. Now coming back to the question, the solenoid carries current. The current in the solenoid is changing from 2 amperes to 4 amperes in time 0.1 second, and there is a loop of area 2 centimeters square inside the solenoid. Now coming back to the flow chart again, which I had given in part 1. Because of current there is induced magnetic field. Because of the magnetic field you have flux. When there is change in flux, that is d phi dt, there is induced EMF, and because of the induced EMF there will be induced current. So induced EMF can be written as being equal to d phi by dt as per Faraday's law. So phi is equal to B dot A, that is BA cos theta. So this d phi dt which causes induced EMF, we need to find out what is the reason of this d phi dt. There could be d phi dt due to B, due to A, due to theta, because phi is equal to BA cos theta. So d phi dt could be either due to dB dt or due to dA dt or due to d theta dt. Now in this case, the induced EMF, the EMF is getting induced in the small loop which is placed inside the solenoid. So in this d phi dt, this phi is with respect to the flux linkages of this loop. So since we are not changing the area of this loop, dA dt will be equal to 0. Since we are not turning the loop with respect to the magnetic field produced by the solenoid, d theta dt will also be equal to 0. The only thing that is changing is the magnetic field, that is dB dt, and B is equal to mu naught Ni. So there is dB dt due to change in current, that is mu naught Ni di dt. So B we have found out from Ampere's Circuital law as being equal to mu naught Ni. So d phi dt can also be written as A cos theta mu naught N di dt. Theta is equal to 0 because the area vector of the loop and B are in the same direction. This theta is the angle between area vector A and B. And we have seen that the loop is placed normal to the axis of the solenoid. So the angle between A and B is equal to 0. A is the area vector which is given by the normal to the area of the plane. Normal to the plane. So theta is equal to 0. So d phi dt becomes equal to A mu naught N di dt. N is the number of turns per meter. A is the area of the loop, and mu naught is the permeability constant, which is given as 4 pi into 10 to the power minus 7. So induced EMF is equal to d phi dt. d phi dt is due to A into dB dt. Since theta is equal to 0, cos theta becomes equal to 1. So this can also be written as A into mu naught N di dt, which is equal to A into mu naught N di dt is 2 by 0.1. The current changes from 2 amperes to 4 amperes in time 0.1 seconds. So di dt will be equal to 4 minus 2 by 0.1. What is area? Area is given as 2 centimeters square. So 2 into 1 by 100, we are converting it into SI unit, into mu naught can be given as 4 pi into 10 to the power minus 7 into n. N is the number of turns per meter. So the question says it has 15 turns per centimeter. So 1 centimeter has 15 turns. 100 centimeter, that is 1 meter, will have 1500 turns. 1500 turns. So we can put the value of n as 1500 into 2 by 0.1. So this, when we calculate this, we get induced EMF is equal to 7.5 into 10 to the power minus 6 volts. So in case of any clarifications, you can log on to www.olympiadtester.com/mentor.